Welcome to chemistry.
In this video, we're going to talk about polarity. So up on the board, you can see a bunch of different molecules of the 5 shapes that you're responsible for. So we have tetrahedral, linear, trigonal planar, trigonal pyramidal, and bent. And what we're going to do is we're going to look at the factors that determine whether or not it's polar, which will usually dictate whether or not it's going to dissolve in water or oil. So the first shape we're going to take a look at is tetrahedral. So we have 2 tetrahedral molecules, one that's polar, one that's nonpolar. If we use the electronegativities, which is the strength an atom has when attracting electrons in a bond, we can determine which way the electrons are going to be pulled within the molecule. So for this first one, CH3Cl, what you have is the hydrogens having a lower electronegativity than the carbon, and then the carbon having a lower electronegativity than the chlorine. So the bond dipoles go towards the carbon from the hydrogen and the chlorine from the carbon. And that would result in a net dipole or molecular dipole that flows this way within the molecule. We use these delta symbols to represent partially positive and partially negative ends of the molecule. So because this is asymmetrical, we can say that it would be a polar molecule. Now, the next one, CF4, or carbon tetrafluoride, the fluorine is the most electronegative element. It has an electronegativity of 4.0, so it's going to be pulling the electrons away from the carbon. But it's pulling equally in all directions, and it's symmetrical. So we would say that that is a nonpolar molecule. Now, there would be a partial negative charge around each of the fluorines and a partial positive charge around the carbon, but I'm leaving that out because I don't want you to think that the molecule's like charged. Then we're going to take a look at linear shapes. So we have carbon dioxide and HCN. So in this case, we have a very symmetrical molecule. You have the same atoms bonded around the central atom. So in this case, even though the oxygen is more electronegative, it's pulling equally in opposite directions, so that there's no net dipole. And because of that symmetry, we would say it is a nonpolar molecule. Whereas HCN, hydrogen, has a lower electronegativity than carbon, which is a lower electronegativity than nitrogen. The electrons all flow towards the nitrogen end, making that end partially negative, hydrogen partially positive. Trigonal planar, BF3, that's a very symmetrical molecule. We would say it's nonpolar. And again, you would have partial negative charges on the fluorine. There should be 3 unshared pairs on that. But, and a partial positive charge on the boron. But overall, it is a nonpolar molecule. Formaldehyde, CH2O, is another trigonal planar molecule. However, not symmetrical. It's polar. The more electronegative atom is oxygen. That's where the electrons would flow to. That's partially negative. And the other end is partially positive. Now, those 3 shapes could be polar or nonpolar depending on what's surrounding the central atom. If it's all the same atoms around the central atom, nonpolar. If it's different elements bonded to the central atom, it's polar. And the last 2 we're going to look at are always polar. If you have an unshared pair of electrons on the central atom, it's always going to be polar. It's going to have some element of asymmetry. And again, the electron density would flow towards the more electronegative element.